Somewhere in the darkness, far beyond the last planet, a cold little machine is still moving. It has no combustion engine, no light in any window. It is older than most of the people who are still listening to it, and every year it loses another part of itself. Yet, it has not faded away. It is still speaking, and what it keeps telling us, from a place no human hand can reach, should have been impossible to know. It has touched an invisible wall, where the solar wind finally dies out. It has heard a sound in a hidden corner of the universe that should only contain silence. And every message it sends now takes nearly a full day to cross the endless void and reach us. So stay close, because two silent questions hang over everything that is about to happen. What is this dying traveler still discovering at the outermost edge of the solar system? And how much longer can it keep talking before the final darkness steals its voice? You first have to know where our solar system actually ends. It does not end at Pluto. It does not end at the last thing your eyes can see. It ends at a place called the heliopause. So, picture our sun not just as a light in the sky, but as something breathing. Every second, it blows out a thin wind of charged particles in all directions, and that wind inflates a giant bubble that surrounds us all, surrounding every planet, every moon, surrounding you, me, and everyone who has ever lived. The heliopause is the coastline of that bubble. That is where the solar wind becomes too weak to push back the faint material floating between the stars. It is not exactly a wall. It is where two tides meet. The outward breath of the sun and the cold sea of the galaxy, leaning against each other until neither side can push any further. On August 25, 2012, a single machine crossed that boundary. Voyager 1 left the protective bubble and became the first human-made object to enter interstellar space. About 11.5 billion miles from Earth, which is roughly 18 billion kilometers. But here is the strange part. Voyager did not see any signs out there. No fence, no door, no sign at all. So how could a machine know that it had truly left the solar system? It knew because it felt the shift. An instrument on board, called the cosmic ray system, constantly counts the tiny particles flying by. And in just a few days, the amount of cosmic rays flooding in from deep space jumped by more than half, while the particles from our sun almost completely vanished. It felt like stepping out of a warm house straight into the middle of a blizzard. Voyager did not read a map. It was like a swimmer suddenly feeling the water become cold and still, and somehow understanding, without anyone telling it, that it had drifted into a new place. Before we cross that invisible boundary with Voyager, where are you watching from tonight? Share your location in the comments. It is strange to realize that all those places fit neatly inside the tiny bubble we are about to leave. And crossing a boundary you cannot see only raises a harder question. What could prove, beyond any doubt, that this old machine had truly entered another world? The answer was waiting in what it could hear. For years, scientists debated what interstellar space would actually be like, and almost everyone expected the same thing. Out there, outside the sun protective shell, space would be emptier, thinner, like true nothingness. So when Voyager flew through, it found something that completely flipped that idea. The void between the stars was not emptier, it was thicker. As Voyager moved into interstellar space, the density of the plasma around it, the thin soup of charged gas filling the galaxy, jumped by about 40 times. Inside the solar bubble, near the edge, the gas is incredibly sparse. Just outside of that, the gas is many times thicker. It turns out, the galaxy is pressing down harder than the final breath of our own star. The edge is not where space thins out. It is where space pushes back. Yet, even if it is 40 times thicker, interstellar space is still emptier than anything we could ever build. The best vacuum chambers on Earth, the cleanest empty containers we can create in a lab, still hold more particles than the space Voyager is currently floating through. Thicker is only true compared to the solar bubble. Compared to us, it is still an almost perfect empty void. But how could Voyager measure this? Its actual plasma detector had been broken since 1980. So, it did something smarter. It listened. The plasma out there vibrates, like a struck bell, at a certain pitch, and that pitch depends on its density. Imagine tapping on a glass of water. A full glass will make a low sound. An empty glass will make a high sound. Voyager could not touch the plasma, so it heard the plasma vibration, and from the pitch of that vibration, it calculated the density. The measurement came in April 2013, when an eruption from the sun made the surrounding gas ring out, and Voyager finally heard the true music of interstellar space. If the idea that the edge of space is thicker rather than emptier flipped how you picture the universe, type the number 1 below. Then, pay close attention, because the next thing Voyager found completely broke all the rules. Because after it crossed the boundary, scientists braced themselves for the next thing their models had predicted. The exact moment when the magnetic field would swing around and point in a new direction. But reality was not like that at all. Every model said the same thing. The solar bubble has its own magnetic field, winding through it like invisible grain in wood. And outside the bubble, the galaxy has its own magnetic field too, pointing a different way. So, when Voyager finally entered interstellar space, its compass should have swung wildly, suddenly turning to follow the galaxy's new magnetic field. It did not change direction at all. Voyager 1 measured the magnetic field out there, and its direction barely shifted. The field was stronger, yes, but it still pointed in almost exactly the same direction as the field inside the bubble. The models were wrong. Imagine walking across the border between two countries, certain that your compass needle will snap to a new direction the moment you cross. But instead, it stays still pointing the old way, as if the border you just crossed meant nothing. That was the puzzle Voyager brought to us. And the wonderful thing is, the scientists were not embarrassed about being wrong. They were thrilled. Because being wrong is how you learn that the universe is stranger and more orderly than you ever imagined. How do we know this is real? and not just a broken instrument fooling itself. Because the measurement came from an instrument called a magnetometer, and then, 6 years later, Voyager 2 crossed that exact same boundary on a completely different trajectory and found exactly the same thing. Two machines, billions of miles apart, telling the exact same impossible story. The meaning of this phenomenon is still not entirely understood. Somehow, the solar bubble and the galaxy magnetic field are aligned far more perfectly than anyone predicted. Scientists still call this one of the biggest surprises of the entire mission, a small mystery hovering at the edge of everything we know. That boundary kept breaking its own rules. But the strangest discovery was not what Voyager saw, nor what it measured. It was what it heard. A sound brought back from a place where there should only be silence. And years later, this very machine, the machine that taught us how to listen, descended into a terrifying silence of its own. If you feel this video deserves to be seen by more people, hit the hype button right below. Every hype helps this video get recommended more. Before Voyager could cross the boundary, it had to pass through a kind of gateway. And that gateway was completely different from anything in the textbooks. On its final leg inside the bubble, Voyager 1 drifted into a strange, stagnant region. A zone almost 9 times the distance from the Earth to the Sun, where the solar wind almost came to a halt. The outward breath of the Sun, which had pushed the spacecraft for decades, simply stopped moving outward. And then it reached what scientists call the magnetic highway, a place where the Sun magnetic field lines and the galaxy magnetic field lines connected, allowing charged particles to move in and out far more freely. An invisible river of fire flowing right at the doorstep. And right behind that door, Voyager discovered heat. The plasma in interstellar space was much hotter than expected, sitting anywhere between 30,000 and 50,000 degrees. But here is the catch, because this is the kind of information that sounds wrong. That temperature would not burn you. It would not even warm you up. Picture a few stray sparks flying around a massive, freezing cold room. Each individual spark is blazing hot, but the room remains cold because there are too few sparks and they are too far apart. That is interstellar space. Every particle is moving incredibly fast, which is all temperature really means, just the speed of particles. But they are spread so thin that Voyager never actually warms up. Heat without warmth. A wall without bricks. By the way, this measurement came from Voyager 2, because its sister ship plasma sensor broke long ago, and only the twin could measure the temperature of the doorway directly. And right at the crossing point, Voyager pierced through a thin, densely packed layer where the gas slowed down, became twice as thick and heated up, like water rising and churning where a wave hits the shore. A buildup right at the edge of the bubble, the final turbulence before reaching the vast open sea of the galaxy. That breakthrough kept overturning everything we expected. And then it produced a sound that no human ear had ever heard before. For a long time, Voyager only heard the edge of the solar system making sounds in bursts. Occasionally, the sun would erupt, sending a shockwave of energy that slammed into the interstellar gas, making it flash and crackle, like distant thunder echoing in the dark. Those eruptions were massive, sudden, and rare. And between those eruptions, scientists assumed there was absolutely no sound to hear. They were wrong. In 2021, researchers analyzing Voyager 1 data found something no one had ever recorded before. Beneath the silence, beneath the occasional explosions, there was a sound, a faint, steady, narrow hum, ringing out at a frequency of about 3 kilohertz, and it never stopped. It was not thunder from the sun, it was the interstellar gas itself, vibrating gently, a continuous note, humming from the very material that fills the space between the stars. This discovery came from a young researcher at Cornell University named Stella Koch-Ocker, who described it as the faint, persistent hum of interstellar gas. The sound is very quiet, very steady, because it exists in a very narrow band of sound frequencies, and its significance is massive. That steady hum meant Voyager no longer had to wait for the sun to light up the plasma. It could now measure the density of interstellar space continuously, listening to the heartbeat of the galaxy in real time. So here is what that means for us. Before, we only heard the echo when the sun roared and the darkness answered back for a moment. Now, we can hear the darkness humming to itself, the soft, restless sound of a room we always believed was empty. We are no longer listening to thunder. We are listening to the breath of interstellar space, a sound coming from a place where, according to every rule we ever wrote, there was not supposed to be any sound at all. And the strangest part is, who was doing the listening? A dying machine, smaller than your car, built half a century ago, is the only ear the entire human race has ever had to pick up that sound. When that ear finally closes, the hum will keep ringing out, unheard, exactly as it has for all the ages before we arrived. And if the thought that the darkness itself has a voice gives you chills, share this with someone who still looks up at the night sky and wonders. Some things are too strange and too beautiful to keep to yourself. But Voyager 1 is only half the story. Somewhere far away, on a different path out of the solar system, its twin was about to do what its brother never could. Almost every story you hear about the edge of our world revolves around Voyager 1. The first ship to cross over, the record holder, the famous ship. But it has a twin, and that twin reached out and touched the edge in a way Voyager 1 never did. On November 5, 2018, Voyager 2 also crossed the heliopause, on its own trajectory, about 119 times farther from the Sun than Earth is, and it carried a precious advantage. Remember how Voyager 1 plasma detector broke in 1980, forcing it to guess the density by listening to the gas ring out? Voyager 2 plasma instrument was still working, so when it crossed the boundary, it did not have to listen and deduce. It directly measured the cold, dense interstellar gas. It was the first time in all of human history that we touched the material between the stars with a working hand, instead of inferring it from echoes. The quiet, forgotten twin gave us the most direct measurement we have ever had, and it did something equally important. From a completely different door, billions of miles away from its sibling, Voyager 2 confirmed the exact same strange findings. The magnetic field that barely changed. The unexpected wall of heat. When two machines, on two separate paths, bring back the same unbelievable answers, it stops being a coincidence and becomes the truth. Imagine them like two sisters leaving home in two different directions, knowing they will never see each other again, each sending back half of the same picture. One listens, one touches. Together, they gave us the only true look at the doorway leading us to the Milky Way. So let us be honest. After meeting both, are you Team Voyager 1, the lone pioneer leading the way, or Team Voyager 2, the quiet twin that hardly anyone ever talks about? Let us know your opinion in the comments. That leads to the question most people ask first. How is something built in 1977 still alive, still working, still whispering to us across the endless void? Put those two boundary crossings together, and a miracle appears. For the first time, humanity could start to see the true shape of its home. Not the planets, not the sun, but the space bubble itself. That bubble has a name. It is the heliosphere. It is the giant cocoon blown out by the solar wind, stretching far past the most distant planet and wrapping around every world inside. And it does something we rarely think about. It shields us. The galaxy is full of high-energy cosmic rays, tiny particles tearing through space at terrifying speeds that can rip living cells apart. The heliosphere blocks most of them before they ever reach us. It is an invisible shield, and every creature that has ever lived on Earth has spent its entire life safely inside it, without ever knowing it existed. The fish does not know it is swimming in water. We did not know we were sheltering inside a bubble blown by a star. Voyager 1 and Voyager 2 are the only two probes to ever measure the edge of that shield from the inside out. And what they found means much more than simple curiosity. Understanding our bubble helps us understand the shelter that allows life to exist here. It even tells us something tender about the rest of the galaxy. Every other star must also blow its own bubble, a small shield around any worlds that might orbit it. Across the galaxy, countless invisible cocoons, each one a zone of peace carved out of the storm. And so far, ours is the only cocoon whose edge we have ever touched. We do not even know exactly what shape it takes. Is the heliosphere round, like a floating balloon? Or does it have a long tail trailing behind it, like a comet hurtling through the galaxy? The debate is still open, and Voyager has given us two precious, rare data points of reality to test it against. Two tiny points of certainty in a vast expanse of the unknown. But to send any answers home, this old machine has to quietly perform a miracle every single day. And the way it does it would put almost everything we build today to shame. Both Voyager probes were launched in 1977. Voyager 2 launched first, on August 20th. Voyager 1 followed on September 5th. And here is what leaves everyone stunned. They were never designed to do all of this. The original mission was only planned for 4 years, just long enough to fly past Jupiter and Saturn, taking advantage of a rare planetary alignment that only happens once every 176 years. 4 years. That was the promise. Nearly 5 decades later, both machines are still sending back real scientific data from the dark. So how do you build something in the 1970s that outlasts almost everything built since. You have to build it the way the engineers of that time did. They designed Voyager with multiple layers of redundant backups for a mission they thought would be over in a few years. And they built it so well that it has outlived generations of modern, disposable technology. The phone in your pocket might not survive a drop on the floor. Voyager has survived nearly 50 years in the coldest and harshest environment imaginable. And it is smart in ways far beyond its time. Voyager was one of the first spacecraft built with computers that could be reprogrammed remotely after launch while in flight. Before that, a probe software was frozen the moment it left the ground. That very design choice, made in the 1970s, is the reason we can still communicate with and repair Voyager today across billions of miles. It even stores its data on an 8-track digital tape recorder, a half-inch tape, over 1,000 feet long, spinning steadily in the freezing cold of space. From launch, through the grand tour of the planets, and all the way out to the edge of the solar system. A mechanical tape recorder, working for almost half a century, in a place colder than almost anywhere in nature. For many people watching, this is very personal. Some of you were children when it launched. Some were born the exact year it left the dock. Voyager is not just a spacecraft. To an entire generation, it feels like a friend who set sail the year you were born, and somehow is still out there, still continuing the journey. But that endurance comes at a cost, because the very thing keeping Voyager alive is slowly and silently running out. Voyager does not run on sunlight. Where it lives, the sun is just another star, far too dim to power anything. So it carries its own source of heat. 3 generators that convert the heat from the slow decay of plutonium into electricity. A tiny nuclear heart, beating in the dark. When Voyager launched, that heart produced about 470 watts of power. By 2023, it was down to around 225 watts. A heart that is fading away, beat by beat, with no way to restart it. And the reason lies within the metal itself. The fuel is a type of plutonium that loses half its heat after about 88 years, a piece small enough to hold in 2 hands, powering the farthest signal humanity has ever sent. But the machine is degrading faster than the fuel, because the parts that convert the heat into electricity are also wearing out. Add it all up, and the power drops by about 4 watts every year. Steady, quiet, unstoppable. To survive on an ever-shrinking supply, NASA has had to make heartbreaking choices. They are turning off Voyager instruments one by one, like someone walking through a house at night. Turning out the lights in each room to keep the last candle burning as long as possible. In February 2025, they turned off an instrument on Voyager 1. In March 2025, another one on Voyager 2. In April 2026, yet another instrument went dark. Every time an instrument is shut down, Voyager loses one of its senses. A way of touching the universe, gone forever. But it willingly gives them up. An eye, an ear, a fingertip, just to keep its voice alive for a few more years. The goal now is simple, and quietly carries a sense of sorrow. To keep at least one instrument running into the 2030s. And then, sometime after that, the final instrument will shut down too. And if this small, fading machine still quietly working after all these years, has earned a bit of your respect tonight. Leave a like before we move on. It only takes a second, and somehow, it feels like keeping it company. And yet, as faint as it is, as nearly blind as it is, it still finds us. Across a chasm so vast that the word far no longer has any meaning. Here is an almost unbelievable number. The computers aboard Voyager have only about 70 kilobytes of memory, all of them combined. That is smaller than a single photo on your phone, smaller than a short email without an attachment. The machine that crossed the interstellar boundary, that heard the hum of the galaxy, has millions of times less memory than the cheapest phone you can buy today, and it stored its discoveries on that magnetic tape. Now compare that to what it accomplishes. With less power remaining than the small light bulb in your refrigerator, Voyager still sends a signal over 15 billion miles, or more than 24 billion kilometers, back to Earth. That signal travels at the speed of light, the fastest speed in the universe, and it still takes about 23 to 24 hours to reach us, just one way. So when we hear Voyager signal today, we are hearing from where it was yesterday. To catch such a faint whisper, we need one of the massive 70-meter diameter antennas of the Deep Space Network. Giant ears straining to hear a voice softer than a breath. Imagine shouting across a continent, in a whisper, and somehow still being heard. That is what happens every day. And that distance is almost impossible to comprehend. Voyager is hurtling through space at about 38,000 miles per hour. And even at that speed, after nearly half a century of relentless flying, it is only just about to cross one light day. One light day is the distance light travels in a single day. That is how far a tiny machine has traveled. Look at the device you are watching this on right now. Phone, television, laptop. Tell me what it is in the comments. Then, think about this for a moment. It has millions of times more memory capacity than the machine still whispering to us from 15 billion miles away. That makes what happened in November 2023 almost unbelievable. Because for a time, that whisper stopped making any sense at all. On November 14, 2023, Voyager 1 started beaming back nonsensical signals. Its carrier signal was still there. The steady tone that says, "I am still alive," still reached Earth right on time. But the data it carried had turned into gibberish, an endless, meaningless string of zeros and ones, as if the machine had lost its ability to form words. It was still alive. It just could not say anything we could understand. And it was 11 billion miles away from Earth. For months, engineers worked tirelessly to figure out what went wrong. In March 2024, they sent a gentle command, a kind of nudge, asking Voyager to send back a complete readout of one of its memory systems. A reader at the Deep Space Network decoded that data dump and slowly tracked down the bug. A single memory chip had failed. Just one single chip. A tiny chip holding only a few hundred words of memory. It had corrupted about 3% of the flight data system, including a piece of code Voyager needed to communicate. Why did it break? Maybe it simply wore out after 46 years in space. Or maybe a single high-energy particle from deep space struck it and damaged it. Either way, the lesson is truly humbling. Out there, Even memory is eroded by time and radiation. But here is what will amaze you. The engineers could not replace the chip. They could not even reach it. So instead, they rewrote Voyager code, broke it up into pieces, and stored those pieces in other working memory banks, then beamed the entire rescue plan across 15 billion miles. A single round-trip command takes about 45 hours just to get there and echo back. Send a command, then wait nearly 2 days to see if it worked. And it worked. Engineering data returned in April 2024. Science data followed in May. By June, all functional instruments were back online. We reached across the widest gulf humanity has ever crossed, and taught a dying 47-year-old machine how to speak again. We saved it, but we cannot save it forever, because Voyager is still moving away, always moving away, heading toward places where no message of ours can follow. Voyager 1 is the farthest and fastest vehicle we have ever built. It is traveling at about 38,000 miles per hour, which is roughly 61,000 kilometers per hour. Back in 1998, it passed an older probe named Pioneer 10 to become the most distant human-made object in existence, and it has never lost that title since. For nearly 30 years now, with every passing second, it breaks its own record, setting a new milestone for the farthest distance humanity has ever reached, only to break that record a moment later. Today, it is about 172 times farther from the Sun than Earth is, so far away that the Sun itself just looks like a bright star. And on November 18, 2026, it crossed a threshold no machine had ever reached. Voyager 1 became the first human-made object to be a full light day away from Earth, about 16 billion miles. Think about what that really means. Light, the fastest thing in the universe, the speed that nothing can surpass, now takes an entire day to travel the distance between us and that little machine. And let us try to put this into perspective. After nearly half a century of continuous flight, Voyager has only just traveled one light day. Just one day. Meanwhile, the Milky Way galaxy, it is drifting into stretches for hundreds of thousands of light years. Picture that. An entire lifetime of travel, the longest journey in human history, and the result is just a single step out the front door, stepping onto a road that stretches on forever. We are a young species, taking our very first steps into something unimaginably vast. And Voyager still has a few major milestones ahead, and I plan to cover every single one of them. If you want to ride along with this veteran traveler for what comes next, make sure to like the video, subscribe to the channel, and join us for the rest of the journey. It will keep going long after the last instrument shuts down. The question is no longer what Voyager will discover. The question now is where it will be when everyone who built it has passed away. So where is Voyager actually heading? The answer gives you a lot to think about. Encircling our entire solar system, far beyond the planets, there is thought to be a massive shell of icy worlds called the Oort cloud, the frozen outer edge of the solar system. Voyager is still about 300 years away from reaching the inner edge of that shell, and after that, it will take another 30,000 years to fly through it. We have never even seen the Oort cloud directly. It is so far away, so incredibly faint, that our best descriptions of it are still just careful, educated guesses. Voyager will be drifting through it long before we can ever see it. And once it finally escapes all of that, Voyager will just drift. In about 40,000 years, Voyager 1 will pass within about 1.7 light-years of a small star named Gliese 445 in the constellation Ursa Minor. But pay attention to the word pass. It is not arriving anywhere. It is not landing. It will simply drift silently through the empty space nearby, and then keep moving into the dark. To feel just how long that time is, brace yourself. The entirety of recorded human history, every story, every empire, every name we have ever written down, only spans about 5,000 or 6,000 years. Voyager will drift for many times longer than all of that history combined, just to pass by, not even touch, the first star on its path. Everyone you have ever known, every city, every language, will be long gone, and it will still be falling through the darkness, only just beginning its journey. It is not going anywhere. It is simply falling forever through space, carrying a tiny piece of us. 40,000 years from now, Voyager will drift past another star. Do you think anything will find it? Just comment yes or no. There are no wrong answers here, only curiosity. Because it will not arrive empty-handed. Bolted to its side is a message. Not for us, but for whoever, or whatever, finds it next. On every Voyager probe, there is a golden record, a copper disc, plated in gold, bearing the image of an entire world. On it are 115 images of Earth, the sounds of our planet, the wind and rain, a heartbeat, music from cultures around the globe, and greetings in 55 different languages. It is a self-portrait of humanity, sealed and sent into the night, with the hope that someday someone will open it. And the people who created it thought very deeply about deep time. The record was built to last over 1 billion years, longer than almost any trace we will leave on Earth. Cities will crumble, mountains will erode, and that little golden record will still be floating, without a scratch, in the silence. On its cover, they attached a small, pure piece of uranium, a radioactive clock. Uranium decays at a perfectly steady rate, so whoever finds Voyager can measure how much is left and calculate exactly how long the record has been floating since it left Earth. A silent message, recording its own age, counting down across billions of years. But the most touching part is this. The cover is designed so the reader does not need to know a single human word. It shows a stylus and a record, marks the required spinning speed, and measures time using the vibration of a hydrogen atom, the only thing that works exactly the same everywhere in the universe. We tried to communicate with strangers we will never meet, using the only language the entire universe shares, the language of physics itself. Voyager is not just a probe. It is physical proof that there was once a civilization that looked up and reached out into the dark. But records do not know grief. Only the people who made them know grief. And one of them, the man whose name became almost synonymous with the Voyager spacecraft itself, is no longer here to listen. Voyager will not die in fire. It will not explode. It will not crash, nor will it sink. When its final bit of power runs out, sometime in the coming years, it will shut down its last instrument, and then one day, it will simply stop working. From Earth, it will not look like death at all. There will be no dramatic final message, no dying words. The signal will simply fail to arrive one day, and then it will never arrive again. And Voyager, completely unaware that it is all over, will keep drifting, exactly as it always has, carrying our golden record into an endless silence. The most distant object we ever created, plunging into the dark without a sound, with no one out there to notice, and it is outliving the people who made it. Ed Stone was the chief scientist of the Voyager mission. He took on that role in 1972, 5 years before the spacecraft left the ground, and he held that position for 50 years, until 2022. For half a century, his voice was the calm voice explaining every Voyager discovery to the world. Patient, careful, never exaggerating. His name and the mission became almost one and the same. He passed away on June 9, 2024, at the age of 88. The machine he cared for his entire working life is still out there tonight, still speaking, still sending its faint reports home. It is just that no one is sitting at his desk to hear them anymore. And he is not the only one who has left. Many of the engineers who built Voyager with their own hands are gone too. The spacecraft has quietly outlived its creators. There is something almost too tender in that. The people who taught it to speak are slowly falling silent first, and soon it will continue to whisper to a world where no one remembers making it. A child, still calling home, long after the parents who sent it away are gone. The house is empty, and no one knows its name anymore. And perhaps that is the most human thing in this whole story. The fact that we built something to outlast us, and then ended up loving it. If you have watched this far, it means you really care. Do not just stop at the like button, hit hype as well. It only takes a few seconds, but it helps this video go many times further. So we are back to the two original questions. What is this dying traveler still discovering at the edge of the solar system? And how much longer can it keep transmitting its signal? And now we know the answers to both. Every faint signal Voyager sends today carries two meanings at the same time. It is the last real scientific data we can gather about the edge of the solar system. The final numbers from the only place we have ever truly reached. And it is a long, slow goodbye, stretching out over years, fading more with every watt of power this tiny heart loses. Why does all of that matter? Because Voyager has taught us things we could never have learned any other way. It showed us the true shape of the bubble that shelters life on Earth. It proved that interstellar space is not empty, but filled with pressure, heat, and a quiet, endless hum. No one could have known that from down here, looking up. We had to go. We had to travel out and feel it directly, with a tiny machine, bought with almost 50 years of patience and care. And there is one last way to grasp all of this. It is easy to look at Voyager, alone in that endless dark, and feel incredibly small. But that is not the real story. The real story is the exact opposite. A small and fragile species, on a single pale blue planet, reached out so far that it learned how to listen to the breath of interstellar space. We did not cower before the universe. We reached into it, farther than anything living has ever reached before. And we are still listening, even now, even as that voice is slowly fading away. Is it silly to mourn a machine? Or is loving the things we create exactly what makes us human? Please share your honest perspective in the comments below. Voyager has shown us the true boundary of the solar system, the real coastline of our home. And even now, even as it dies, it continues to send that knowledge back. A tiny machine from 1977, with a fading nuclear heart, is still the farthest eye and the farthest ear humanity has ever possessed. And when it finally goes silent, it will not stop. It will keep drifting, carrying our golden portrait into a future that none of us will ever witness. A little traveler, still whispering in the dark, long after the dark has stolen its voice. If you want to be here when its final signal arrives, you know what to do.